So you can start.
Okay. So, yes, good evening, everyone. This is Dr. Abhijeet. And today we are going to discuss the sphingolipids and eicosanoids. Now, we have initiated a 90 days foundational life class for the university exams, where I will be revising the important questions, the potent questions for the upcoming prof exam. Apart from that, I will be covering all the important volatile topics that are, I personally believe that are necessary to revise just before the exams, right? And from the past 10 years, whatever questions have been asked in various university prof exams, I will be covering that also. So it is beneficial for everyone who's going to appear for the upcoming prof exam, along with the ones who are going to appear for the next exam. Now, so these are the questions that I will be focusing in today's discussion. We have the long essays that will be comprised of 10 marks, the short essays that are comprised of 8 or 5 marks. Then we have the short answers that are comprised of 3 or 2 marks, right? So I will be discussing the part 3 of the lipid biochemistry. I will be discussing the part 3 of the lipid biochemistry today. And today I will be focusing on the sphingolipids, right? Their role in the nervous system, right? I will be discussing some importance about the prostaglandins, right? So that will be like the various no eicosanoids. Okay, I will be discussing this also. So this will be the point of discussion for today, right? Now, guys, you already know about the Oracle app. So what are the features, guys? You itself know it that we have the recorded classes. Once you like miss the live classes, you can just go on for the recorded ones. We have the live classes that we are conducting like almost daily basis on YouTube. Okay, we have the practical sessions which are recorded, okay, in the app. We have the exam module sessions where everything is covered under 20 hours, right? Just before the exams, you cannot read lengthy textbooks and you just need to find a short way to know cover all the topics. So that will give an extra edge for this. And we have a hard copy book set. Okay, that is something very so this feature is like, yeah, you can just order all the notes because I personally believe you cannot read the textbook just before the exam. Again, telling you, books are never a replacement to these notes or something. So standard books are must, but along with that, yeah, just you have like 1 or 2 months left, go for the notes. Now we have the foundational classes, guys, right? We have the live classes. We have the express exam module where everything is covered under 20 hours. We have the one-to-one doubt clearing session where like students can interact with the faculty and yes, can clear all his doubt related with the subject. We have the hard copy no set. You can order it and we'll like it is like home delivery kind of a thing. So it will be delivered to your home. Question banks, guys, I have already told you we have basic to advanced level of questions, right? Basic. Okay, all the new trends that have been included, like the clinical vignettes and all that, that are also covered over here. The last 10 years, NEET PG, INICET exam questions, important topic wise question from basic to from beginners to advanced level, everything is covered. And along with that, we will have an explanation for that particular question as well. Yes. So yeah, the practical sessions we have already spoken about, and this is the basic subscription plan, the foundational plan, the advanced learning plan, the complete learning plan, and the ultimate MBBS plan. So you can use my code Dr. Abhijeet 20 for additional discounts. Now coming on to the very first question for today, describe the structure and functions of sphingolipids, focusing on their role in the nervous system and cell signaling. Now, guys, let us just try to understand what are these sphingolipids. Now, whenever you guys already know, we have started the classification of phospholipids. Okay, in phospholipids, classification of phospholipids? Now, you guys already know we have the glycerophospholipid, glycerophospholipids, and we have sphingophospholipids, right? Sphingophospholipids. Now, what is the basic difference between the two lipids, guys? Already you know that phospholipid, it is a compound lipid. Okay, you already know it is a compound lipid, or I can say it is a complex kind of a lipid. Okay, it is a complex lipid where you basically know the definition of compound or this complex phospholipid, that it is composed of fatty acid plus alcohol plus other group plus other group. Now here the other group, it is phosphate. That's why it is called as phospholipids. So even in the glycerophospholipids, you will be having this fatty acid, alcohol, and other group. Sphingophospholipids also, you will be having fatty acid plus alcohol and other group. That is phosphate only, right? Now, what is the difference between glycerophospholipids and sphingophospholipids? Now, guys, in glycerophospholipid, fatty acid is same, right? The other group, that is phosphate, phosphate is also same. Now, what is the difference between the two? It is the alcohol, guys. It is the alcohol over here, which creates a difference between the two phospholipids, alcohol. Now, what is the alcohol that is in case of glycerophospholipids? That is, guys, you already know we have, yes, we have the glycerol over here. That's why the name glycerophospholipids, right? Over here, the alcohol that is used, that is called as sphingosine, right? The alcohol that is used over here, that is the sphingosine. So yes, that is the backbone of the sphingospholipids. The fatty acids, the phosphate group will be there, alcohol that will be there, that is called as the sphingophospholipid, right? Sphingophospholipid. So sphingosine plus phosphate plus fatty acid will be forming the sphingospholipids. Okay, sphingophospholipid, it is a phospholipid, and you already know phospholipid, it is a compound lipid or a complex lipid which is made up of fatty acid plus alcohol plus other group, that is phosphate. Alcohol can be either glycerol, that is glycerophospholipids, we have already covered in the previous class, and today we are going to main focus on these sphingospholipids, right? Now, let us just try to understand the sphingophospholipid structure. So firstly, you are you are aware what is sphingophospholipid. So you already know that sphingophospholipid, basically the backbone, it is, yes, it is sphingosine, and you already know that sphingosine, it is basically an, okay, it is basically an amino alcohol. It is an amino alcohol. And remember, guys, when I say amino alcohol, and you just have to remember that the sphingosine, it is basically derived from the sphingophospholipid. We have serine plus palmitic acid. Palmitic acid. Okay. So we have serine. Okay. And yeah, along with that, we have the fatty acid that is called as the palmitic acid. Now, guys, let me just try to draw the structure of the sphingosine so that it's very clear to you that we have one carbon that is bonded with the hydroxyl group. The another carbon, I've already told you, it's an amino alcohol. Amino means NH2 group, right? So the second carbon, it is having this amino group, that is NH2. First carbon, second carbon, and the third carbon, guys, it is basically linked to the fatty acid. Fatty acid. Now this above part, It is basically the sphingosine, right? Sphingosine, right? So that is something you have to remember about this, right? So yes, over here, yes, just to balance it, you guys have to remember it is an OH group. So basically, sphingosine backbone, it consists of a long hydrocarbon chain, the fatty acid, right? With an amino group, right? NH2 group, and with two hydroxyl groups. Two hydroxyl groups, okay? So this unique structure, no, guys, will help to form the various derivatives also. And the one derivative that you have to remember, so yes, the one derivative that you have to remember, different sphingophospholipid. So only one is there, guys. Only one that you have to remember. Only one sphingophospholipid, and that is called as the sphingomyelin. 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 No, no. This is the sphingomyelin, right? Now, you guys already know the basic structure over here. We have the three carbons, right? We have the three carbons, one bonded with the NH group, right? The other with the fatty acid group. And we have one carbon that is bonded with the phosphate. And to that phosphate, what is attached, guys? The nitrogenous base. The nitrogenous base, and over here it is the choline. Choline. So we have like three parts, guys. Firstly, you should know we have the sphingosine, right? Then the second part, it is basically, okay, the fatty acid part, right? The third, it is the phosphate part, and fourth, it is the nitrogenous base, that is the choline, right? So remember, guys, the sphingosine, like this whole is the sphingosine plus fatty acid. It is called as ceramide. It is called as ceramide, right? So yes. Now, if I just want to, like, in short, if I have to tell, we have sphingosine, that is an amino alcohol. We have NH group along with the alcohol wala part, right? The OH above also, right? The sphingosine plus fatty acid, okay? Plus phosphate plus choline. Choline is basically a nitrogenous base, nitrogenous base. So sphingosine plus fatty acid, it is called as ceramide, okay? And yes, that is you have to remember. And together it is called as the sphingophospholipid, right? Now, what is the significance, guys? What is the significance? Hmm. Now, this was the like basic structure, guys. So they have asked the structure and yes, the functions of sphingophospholipids. Now, let me just in short firstly tell you about the significance of sphingomyelin. Sphingomyelin. Now remember, guys, it is present in the cell membrane. Important part. It is present in the cell membrane. It is present in certain specialized structures. Okay. So in cell membrane, it is present in certain specialized structure that is called as lipid rafts. It is present in myelin sheath of nervous tissue. Also, it is present in the white matter of brain. White matter of brain. Now, guys, what is exactly the function of sphingofospholipids? Okay, in specialized structures called as cell membrane. Now, these sphingolipids, okay, these sphingolipids, what they do, they contribute to the formation of these lipid rafts, right? And in cellular membranes, which are no, these are micro domains. Okay, these are micro domains that organize the signaling molecules, right? And they facilitate communication between cells, and they facilitate communication between cells, right? So that is one of the function of the sphingomyelin or the sphingolipid over here. Okay, so they contribute to the formation of these rafts, and these are just like the signaling molecules, and they will facilitate communication between the cells. Second, I've told you they are contributing onto this particular structure that is called as the myelin sheath, right? Myelin sheath. So in the nervous system, basically the yes, the sphingomyelin, it is basically a key component of myelin formation, right? So this myelin, guys, you already know, it is the insulating layer. It is the insulating layer that surrounds the axon. That surrounds the axon. Okay. Now this insulation, guys, it is basically due to the sphingomyelin, and that insulation is essential. Why this insulation is essential according to physiology? For rapid propagation propagation of electrical impulses along nerve fibers. That is again very, very important. Along nerve fibers, right? So that is you have to remember in nervous system, the sphingomyelin, it is basically forming the insulating layer, right? It surrounds the axon, and that insulation, guys, is very, very necessary for the movement, for the rapid movement of the electrical impulses along the nerve fibers, right? Nerve cells, right? One of the important function that you all have to remember over here again, it is the cell signaling. So we are talking about cell signaling. Now, these sphingofospholipids, or these sphingolipids, they are involved in various signaling pathways. For example, we have talked about ceramide right now. Ceramide, right? So ceramide basically often it is acting like a pro-apoptotic signal, right? So apoptosis means cell death, programmed cell death. So it is basically regulating cell death, cells which are old, okay, they need to die. So that's the like auto-generated process that is regulated by this particular structure, ceramide. So that is regulating the cell death, right? And differentiation, obviously, right? Apart from that, if we talk about the sphingosine 1-phosphate, guys, along again, these are the same compounds, guys. Sphingosine, okay, with fatty acid is ceramide. Sphingosine, okay, along with the phosphate group, this alcohol along with the phosphate group, it is also acting like a signaling molecule. It is a bioactive lipid. It is a bioactive, yes, it is a bioactive lipid, right? That promotes cell proliferation, survival, and also the cell migration. Very, very important. Okay. Now, this pingosine 1-phosphate in physiology, guys, you might have read about a receptor that is called as the G protein coupled receptor. It is also called as the serpentine receptor. It is just like this structure. That's why it is called as the serpentine, just like a snake. G protein coupled receptor. And obviously, it is very, very important in immune responses. And yeah, along with, yes, the immune responses. Okay. Now, nervous system, we have already talked to you. These sphingolipids are implicated in, right, neuroprotection, right? I've already told you they are the insulating layers, right? So yes, even guys, if you just yeah, we have like two like more. You can just remember, obviously, in the structure also. The let me just use one pen over here. So so basic structure of sphingomyelin, you already know we have a sphingosine, the amino alcohol, right? We have a fatty acid chain. We have the head groups, right? The head groups. So basically, again, if we talk about the ceramides, guys, we have just talked about ceramides. These ceramides are constituting the head groups. So they can be again like classified into two types: the sphingomyelin and glycosphingolipids. Right? Now, when I say sphingomyelin, guys, you already know it contains a phosphocholine as the nitrogenous base, right? Or phosphoethanolamine head group, or phosphoethanolamine head group, right? And they are abundant in myelin sheath and that surrounds the nerve cells. These glycosphingolipids basically they contain, yes, the carbohydrate groups, and they can be like classified into two more structures that is called as cerebrosides and gangliosides. Okay, which have multiple sugar residues, so they can be classified on the basis of this as well, right? So that is yeah, regarding the very first question. We have discussed the cell signaling. Okay, we have discussed the role in the nervous system and the structure also, along with the classification also I've just told you, right? So yes, that was regarding the first question. Coming on to the next question, that is explain the structure. Okay. Synthesis and roles of iconosoids, okay, in inflammation and other physiological process. So let us just try to enumerate the answer over here. So remember that icosanoids, these are bioactive lipid mediators, right? These are bioactive lipid mediators. They are derived from a fatty acid that is called as the arachidonic acid, right? Arachidonic acid. Arachidonic acid, we have already discussed in the last class that it is a polyunsaturated fatty acid, right? It is a polyunsaturated fatty acid, and this is basically found in the cell membrane, right? It is found in the cell membrane, and which component of the cell membrane? That is the phospholipids. Phospholipids. Right, so that is the icosanoids. What are these? These are the bioactive lipid mediators that are derived from arachidonic acid. Arachidonic acid, you already know it is a polyunsaturated fatty acid that is found in the cell membrane in the form of these phospholipids, right? Now, these icosanoids have various roles in various physiological processes, such as inflammation, right? Immune response, homeostasis. Okay. So let us just try to discuss the all roles that are like necessary. Now, if we talk about the synthesis, guys, I have already told you it is derived from the arachidonic acid. So if we talk about synthesis, now The very first thing that the eicosanoids, they are synthesized from membrane phospholipids. Membrane phospholipids, where arachidonic acid it is typically released by the action of an enzyme that is called as phospholipase A2. PLA basically means phospholipase A2, and that is basically released in response to a certain stimulus. Okay, that stimulus can be in the form of injury, infection, or anything, or like cytokine signaling or something like that also. So if there is any injury or infection that is in the form of a stimulus, what it will do, the membrane phospholipids will start secreting, yeah, the arachidonic acid, right? So this arachidonic acid is basically released by the action of an enzyme that is called as phospholipase A2, right? Now, arachidonic acid basically can be synthesized by various pathways, right? So yes, one of the pathways that you will be studying in physiology, guys, that is called as the COX pathway. COX basically means cyclooxygenase, right? Cyclooxygenase pathway. Now, arachidonic acid, I'm just writing AA. Arachidonic acid is converted into prostaglandins, and it is also converted into thromboxans. So there are various COX enzymes, cyclooxygenase enzymes, which are acting on it, and they are converting this arachidonic acid into prostaglandins and thromboxans, right? So basically, we have like two COX enzymes, COX-1 and COX-2, right? Now, these prostaglandins, guys, they are involved in regulating. Now, what they are regulating in the body, they are regulating inflammation, they are regulating pain, they are regulating fever. Okay. And if we talk about thromboxans, again, the name suggests thrombocytes, the platelets. So they play a role in platelet aggregation. So they play a role in platelet aggregation and vascular constriction. Vascular means the blood vessels. They constrict in response to a particular injury, right? Vascular. Obviously, whenever there will be a cut, the blood vessels will try to constrict so that there is limited loss of blood. So that is vascular constriction, right? So that is again you have to remember, okay? Or the other method of synthesis is we are discussing synthesis. So the other method can be the LOX pathway. The LOX pathway. Now, when I say LOX, so you already know it is lipooxygenase pathway. Lipooxygenase pathway. Lipooxygenase pathway. Now, this arachidonic acid can also be converted into leukotrienes by the LOX enzymes, right? By the LOX enzymes. Now, leukotrienes, they are important mediators of inflammatory response, right? So, leukotriene LT1, okay, they are basically, yeah, the inflammatory responses, and you already know they are particularly in asthma and allergic reactions, right? There is one more way of synthesis that is called as, yes, the cytochrome P450 pathway, right? Cytochrome P450 pathway, right? So arachidonic acid can be metabolized into, yes, epoxy eicosanoic acids, okay? That is called as epoxy eicosanoic acids, right? That is called as EETs, okay? And they can be other hydroxy eicosanoic acids, right? So they are basically involved in vascular functions. and inflammation as well. So that is how they are like like synthesized, right? The various mediators of these eicosanoids, right? So yes, now coming on to the role of eicosanoids, the question also says the role. Okay, we are going to discuss the inflammation wala part. The role of eicosanoids. Firstly, it is the inflammation process. We have already discussed this, right? Prostaglandins are the ones, right? Prostaglandins, they are derived from this arachidonic acid, and basically these are nothing but the arachidonic acid only derivatives, right? So prostaglandins basically they promote vasodilation, vasodilation. Blood vessels dilate, vaso, vascular dilation, blood vessels dilation, vascular permeability. They also sensitize nerve endings, right? Contributing to the signs of inflammation, such as the redness, heat, swelling, and pain, right? So, obviously, yeah, in inflammation, you guys will be discussing the rubor part and all that in the second year. But as of now, just remember this. Apart from that, we have the leukotrienes, right? So they are the potent mediators of inflammation. Mediators of inflammation. Now they are promoting chemotaxis. Chemotaxis means attraction of the immune cells, right? Bronchoconstriction, mucus secretion in the respiratory pathway. So all that. Apart from that, they are also involved in immune response. So inflammation is basically by these two. Then we have the immune response, right? So basically, they also like contribute to the activation and recruitment of the immune cells in the body, right? So again, if we talk about prostaglandins also, guys, like we have prostaglandin E2, right? That is involved in the development of fever, okay, and for the sensation of pain also, right? So basically, these prostaglandins, what they are doing, they're acting on hypothalamus, and they are basically acting on hypothalamus to raise the body temperature and sensitize these pain receptors, right? We have already discussed about this thromboxane, guys, that is promotes the platelet aggregation. Thromboxanes basically promote platelet aggregation, right? And vasoconstriction, right? So yes, basically this platelet aggregation, vasoconstriction, they all play a very important role in homeostasis as well, right? We have another prostacyclin also. That's not a point of discussion because all these major parts you will be like more focusing on the pathology in the second year as well. So yes, so icosanoids basically help in maintaining the blood regulation also, right? The blood pressure also. So that is something you just have to remember over here. Coming on to the third question, guys, what is the significance of sphingomyelin in nerve transmission? Now, the sphingomyelin, due to its structure and functional properties, basically it's a very important structure. So, firstly, you already know it helps in the myelin sheath formation. I have already told you it helps in the myelin sheath formation, right? Now, the sphingomyelin, it is a very key component of myelin, right? Myelin, you already know, I've just told you, it is an insulating layer. It is an insulating layer that surrounds axon, that surrounds the axons, right? Now, this insulation, guys, is very much essential for increasing speed of electrical impulses or the action potential, electrical impulses. Now, you already know if this is the axon, guys, right? And the myelin sheath is surrounding that side. And in between, we have a space that is called as nodes of Ranvier. So the myelin sheath is basically not continuous. Okay, it is interrupted at intervals by these spaces that is called as the nodes of Ranvier, the gaps. So sphingomyelin helps maintain the structural integrity of these nodes as well, right? Where ion channels are concentrated. Okay, so the ion channels are concentrated, allowing for the rapid movement, right? Apart from that, guys, you already know it also helps in the yes saltatory conduction. We already have discussed this in +2 as well. Plus 11, right? I mean +1, that is 11th class saltatory conduction. So yes, now saltatory conduction is where no the one action potential jumps from one node of Ranvier to another. Okay, from one nodes of Ranvier to another. Okay, so basically they are jumping and automatically they are increasing the conduction velocity of the nerve impulses. Okay, as compared to the unmyelinated one. So there can be more efficient communication between the nerve cells, right? So yes, that is something you have to remember. Now, apart from that, they are also protecting the neurons. So they are also involved in neuroprotection also. Okay. So yes, proper myelination is basically important for maintaining the health of the neurons. Okay. And that's why you know they are preventing the neurodegeneration also. Right. Even guys, you just have to remember one disorder as well. That is called as the multiple sclerosis. Now, when I say multiple sclerosis, guys, remember this is the disorder that involves the loss of myelin. Loss of myelin. Now, if myelin is lost, the nerve transmission will be impaired. Obviously, the nerve transmission will be impaired. So sphingomyelin helps in the formation of myelin. Sphingomyelin is not there, no myelin formation, no nerve transmission, and again the person will be suffering from multiple sclerosis. Right? So that is like you have to very much like focus on. So that was regarding the third question. What's the significance of sphingomyelin in nerve transmission? Coming on to the next question, that is called as the define prostaglandins and their biological functions, right? You already know. So prostaglandins, basically, they are the group of lipid compounds, and basically they are derived from arachidonic acid. Arachidonic acid, okay, and you already know this arachidonic acid is nothing but a polyunsaturated fatty acid, right? Now they are classified as eicosanoids. We have already discussed they are classified as eicosanoids, right? And play crucial roles in various biological process, right? So prostaglandins basically they are synthesized in nearly all tissues. Synthesized in nearly all tissues. Okay, and act as local hormones. So basically they affect primarily in the tissues. Now, what are the biological functions? If we talk about the biological functions, firstly, I've already discussed that it plays a various important role in inflammation. So they are key mediators of the inflammatory response, right? They promote vasodilation. They promote, they increase blood flow. Vasodilation, increase blood flow, enhance permeability of blood vessels, right? And obviously, if permeability is increased, they will contribute to redness, okay, rubor, the heat, the swelling, okay, and pain that is associated with inflammation, Apart from that, okay, if we are like talking about pain, guys, now certain prostaglandins, if we talk about especially PGE2, okay, these prostaglandins basically they sensitize Nociceptors. Okay, nociceptors. Okay, these are basically the pain receptors. These are basically the pain receptors that are there present in the tissues. Okay, leading to increased pain perception. So basically, they are no, they play a very significant role in one of the drug mechanism, that is non-steroidal anti-inflammatory drugs, which inhibit their like action, right? Non-steroidal anti-inflammatory drugs. Even the fever regulation, guys, the prostaglandin E2, it is also involved in the hypothalamic regulation. I've already discussed hypothalamic regulation. They act on the hypothalamus to induce fever in response to any infection in the body or any inflammation in the body, right? Any infection or any inflammation in the body. Apart from that, they also help protect the mucosal layer of the GIT. Okay, protect GIT layer. Basically, they help in the production of the mucus and the bicarbonate secretion, so that they are protecting the GIT also, right? Even the prostaglandins, they are playing a very important role in reproductive part also. They basically have an important role in ovulation, menstrual cycle regulation, even the pain also, periods pain, right? So that is also like one of the important roles. So these are like, in short, you can just mention about all the important points that I have discussed over here. Coming on to the last question for the day, that is what is the ceramide, guys, and what is its role in cell signaling. So I think this is something which we have already discussed. So yes, so ceramide is basically a type of sphingophospholipid. It is a type of sphingophospholipid phospholipid that consists of sphingosine, that is basically the amino alcohol, right, which is linked to a fatty acid with an amine pod. Okay, so yeah, what is the structure, you already know, right? So we have a long chain amino alcohol that forms the core of the ceramide, right? Now, what is the importance of this cell signaling, guys? You already know that it helps in, yes, the regulation of apoptosis. Regulation of apoptosis. So ceramide is basically a pro-apoptotic signaling molecule that we have just discussed. It is a pro-apoptotic signaling molecule. Okay, it can trigger the cell death by activating specific pathways, right? Such as caspases, right? So yes, even it helps in the inflammation. Okay, so it is involved in mediating inflammatory responses, right? So yeah, apart from that, it is also involved in the lipid raft formation. We have already discussed the lipid raft formation in the cell membrane, right? So yes, lipid raft formation. So these are the micro domains in the cell membrane that organize the signaling molecules, right? So the rafts basically, they facilitate clustering of receptors, okay, and signaling proteins, right? Enhancing the efficiency of signal transduction. Okay, so that is something you guys all have to remember. So yes, that was regarding the today's discussion. That was regarding the today's discussion. All the important questions that we have discussed, all the 5 questions that we have just today discussed. Yeah. So yes, we have discussed the sphingolipids, the icosanoids, physiological process role. Yes, sphingomyelin in nerve conduction. Okay, prostaglandins, important prostaglandins. We have discussed ceramide. We have discussed. Okay, so these are the questions that are like, yes, from today's session. Yes. So Manvi, would you like to just answer the question in the text, like, yeah, in the chat box? The sphingolipids are. Hmm. Found in high concentrations in which of the following tissues? Very good, Manvi. It is the nervous tissue. Very good, beta. I'm so happy. Now, which of the following is a precursor for the synthesis of sphingomyelin? Can you tell me? Hmm. Very good. It is the ceramide. Very good, Manvi. The third question, prostaglandins are derived from which of the following fatty acids? Yes, Manvi, I'm waiting for your answer. Very good, beta. It is the arachidonic acid. Very good, Manvi. Which of the following eicosanoids is primarily involved in the regulation of platelet aggregation? It is thromboxane A2. Very good. Which of the following is the primary function of the sphingomyelin in nerve cells? Yes, it is a formation of the myelin sheath. Very good. All these points we have discussed. Eicosanoids such as prostaglandins and leukotrienes play an important role in. Very good. It is the inflammation and the immune response. Ceramide is a bioactive lipid that is involved in. Very good. It is apoptosis and cell signaling. We have just discussed, right? Which of the following is the key function of prostaglandins in the body? They are, it will not mediate, it will be mediators. Mm, no, they are the mediators of inflammation and pain, right? Prostaglandins are like, they are the derivatives, no? So, yes. Leukotrienes are in primarily involved in which of the following physiological processes? Yes, Manvi. It is the vasoconstriction and, yes, bronchoconstriction. Which lipid acts as a secondary messenger in cellular signaling and is involved in apoptosis also? This I think you know. Yes, obviously, Manvi, very good. That is regarding all the important questions that we have also covered related with this particular topic. And I hope you enjoyed learning it. Yes, thank you. Yeah, thank you for your patience for